So, welcome to our third
It's a training.
and final Quest demo seminar. Today, our topic is WebMathematica and new question types. So I'll start with our new question types. For those of you that haven't used Quest before, we have our normal multiple choice question type that we've always had. And remember that we still randomize our parameters and everything like that. We can change pictures in our questions, we can change numbers in our questions, and then we also scramble our choices. So this is a lot of our question set. But we've also developed several other types over the last year. The first type that we have is a short answer, meaning that we can now accept text submissions from the student. So you can ask a student, what types of asymptotes does this function have? And they can submit either vertical or vertical asymptotes. Those are both acceptable, those are both fine, and we would grade those both as the same. So for the first time in our Quest lives, we have more than one correct answer that we are allowing. Yes?
Now, if someone misspells vertical?
Bad news for them.
How do we know which is the acceptable answer?
So the editor who codes the question says these are acceptable.
How does a student know?
Well, what do you mean?
Well, how does a student know whether to write x equals a, or vertical asymptote, or what?
So if you
Vertical or what?
So if you were posing that question to them, what kinds of asymptotes does this have? Presumably your graph would have just one kind of asymptote, vertical, and so
But
you
you've
would
got
answer
to
either.
telegraph the.
Yeah, I
you've
mean,
got the
yeah, there has to be a clear answer there.
okay.
Does that make sense? Okay, so this is our short answer question body. We can also accept things like, what's the name of this compound? Presumably, in chemistry you have different names for compounds, right? They can have different names. So we can accept either or all of the names that are correct there. It depends on how though the person codes that question. We've also moved on to
Can I stop you quickly?
yeah.
And you're allowed to assign different values for the answers that are given. In other words, if they've got it correct, you get 5 points. If they gave this answer, they would get 3 points.
No. So what we do allow is multiple tries. And so if you get it right on the first try, maybe you get 10 points. If you get it right on the second try, maybe you get 7. But there's no gradation of points for different answers. Does that make sense?
Yeah.
Okay, so we can also accept function expression type answers. So for this particular question, the correct answer is this quadratic expression. And we can accept that as the correct answer. We can accept this, anything that is algebraically equivalent. All of those are considered totally fine and okay. So our ability to validate the correctness of these kinds of things is fairly robust and exciting. We can also now accept answers that are ordered pairs or intervals because the notation is the same. So you can ask a question on what intervals is this function defined, and we can accept this as our answer. So you'll notice though that if you were to ask a question like what's the domain of the function, there's no union there, right? So right now we can only accept lists of these things. So we could say that the function is defined from -2 to 0, pi to 7, and we would appropriately deal with the open and closedness of the brackets. So this is, and the order doesn't matter.
How do they type pi?
We'll get to that. We have a palette.
And you don't have to put braces or anything like that for this?
So this is different. For this, you have to have every ordered pair or every interval has to have an opening and a closing bracket, whether it's round or square. But there is another question type. So, before we move on. And again, we can accept things that are algebraically equivalent. So here, what would you call this? The order of the intervals that you submit doesn't matter. However, the order inside, of course, does. So we account for that. The other thing is that anything that is algebraically equivalent, not that you would want to do this, but a student could, if they wanted to, submit this as their answer, and that would be okay. Yes.
And once again, no partial credit if you get one interval and not the other.
So if you get
Correct.
one interval and not the other, it's counted as wrong, and you get to try again.
But you could code the question such that if there were multiple parts, you could ask separately for each part, and that would allow you to get partial credit.
That's
T. So it's a little bit of a onus on the question writer on how maybe
Yeah.
to structure partial credits.
Okay, so we can also accept now, for those of you that are familiar with our numeric, yes.
I'm sorry to interrupt. I want to just think about the partial credit thing because it's come up twice now. There was a suggestion which I think we're working on at some point, which is to have a hints feature. And so just in the spirit of all kinds of possible partial credit, if faculty members wanted to code it with a question with a hints feature, like the student can't answer, and rather than just guess, click on a button here if you'd like a hint. You get a hint, and then you can proceed to answer, and maybe at lesser credit for the problem. You pay for the cost of getting the hint, and you could maybe get a couple hints, at which point there's no value left in the problem. And that was something that was seen on one of the other web platforms that we're going to try to implement sometime in the future. I don't know where that fits on your queue right now, Shane, but
You can start saving that.
I guess my question was partly, this may be very bad memory from early versions of Mathematica, but if you did a test, the set 1, 2 equals set 2, 3, it would return something like true, false. But I'm guessing now Mathematica no longer returns that, it just returns false.
So right now, we haven't, when we first implemented these, we call them algebraic response question types. When we first implemented these, we talked about whether we wanted to have or require set notation in our answers, and we decided not. So for this, even though you might be asking for a solution set, we are not requiring that the student enter the curly brackets, delimiting the set. And this, the way that we decide whether it's true or not is we separate it at the commas, we take each piece individually and say, is it the same as something in the list that's defined as the correct answer? So the Mathematica part comes in deciding whether the elements are the same, not in the whole collection together. Does that make
So
sense?
you treat lists separately on your own.
Yes.
Your own
Yeah, we do a pre-parsing on them
Mm.
and separate them.
Mathematica runs in the background, and then we deal with what Mathematica tells us as to whether it's right or wrong. I mean, does that make sense?
Yeah, but it means in principle you could have put it differently to pick out partial credit.
Yes.
So Mathematica thinks that lowercase arctangent of 1 is pi over 4?
Yes.
So, yeah, so then you could actually do this where
Well,
Mathematica
there's lots of
could
values.
be just looking through and seeing if it matches any element in the matrix and then scoring it that way. You could have Mathematica return a result that you could then score accordingly.
Yes.
So that'd be a very fast way to get partial credit
But it's
within the
not
question.
implemented yet, okay.
It's not.
Well,
but
and we also need somebody to decide on the problem editor level, what points are you going to give for this particular answer? And what points are you going to give for this particular answer? So that's another sticky part.
Yeah, that would obviously be the question creator's purview.
Any other questions? So we can accept lists of answers, for example, what are the x-intercepts of this function, what are the solutions? And again, anything that is algebraically equivalent is okay. I think that when the types of functions that we now are comfortable with are trig functions, like sine, cosine, tangent, inverse trig functions, the common log, the natural log, square root, absolute value, and rational functions, and polynomials. So our list is pretty solid. We wanted to not in this first pass deal with integral signs or derivative signs or any of